Hello wonderful person, this is Anton, and today we're going to discuss a very strange discovery of what seems to be a kind of a superkilonova. Basically, a never before seen explosion in outer space that definitely surprised everyone in astronomy. And specifically because we've never seen this before, this has never been anticipated or predicted, and seems to involve some kind of a very strange phenomenon that we're going to be discussing in this video. And so let's talk about this recent discovery and some of the studies behind this in a little bit more detail, and also discuss why this particular discovery is so important. But first, as always, you can find all of the studies related to this in the description below. But why was this so unusual, and why was this so bizarre? Well, here the problem is actually pretty simple. For decades, astronomers believed that we had pretty well-defined categories when it comes to various astronomical explosions. For example, we had things like nova, which involve white dwarfs, and we had supernova, which involves collapsing stars. But then in 2017, we also discovered something that was kind of predicted, but never officially observed. This was the first official confirmation that colliding neutron stars eventually produce a very specific type of an explosion referred to as a kilonova. The event that we now understand pretty well, and the event that's almost certainly responsible for the formation of a lot of complex elements, including gold and platinum, that we see all over the place. But in late 2025, the universe delivered an event that broke all of our expectations. A completely new type of an explosion that's a little bit bizarre and is currently just referred to as a superkilonova. Because in this case, the star exploded not just once, but twice. And that's basically the story of the event, whose name you see right here. But to appreciate the event, let's go through some of the differences between these explosions, just so that all of this makes sense. So first, let's talk about the supernova. The powerful luminous explosions that mark the final evolutionary stage of a typical massive star. And so when the star reaches a certain age, its core starts to collapse and produces a powerful explosion. This releases tremendous amount of energy, which then results in the formation of many different complex elements up to iron. And so for example, things like carbon and silicon that's all over the place on planet Earth all came from various supernova. And these events are normally pretty bright. Their peak brightness is usually comparable to the entire galaxy. But they fade pretty quickly over several weeks, and after a few months are barely visible. And so here, a typical supernova is usually described as a kind of a death of a star, although technically it's really a transformation, because the star just becomes something else like a neutron star or a black hole. But obviously supernova are not something that's unusual today, and we see many of them every single year. Here's a really good example of a typical brightness curve for a supernova. In contrast, a kilonova is born from a completely different type of an event. This is a different type of cosmic violence involving the merger of two compact objects. Here this has to be either two neutron stars or a neutron star and a black hole. And normally this is a much shorter and a much fainter event, with the name kilonova literally coming from the fact that these events are usually 1/10 or maybe 1/100th the brightness of a typical supernova. But these events are still significant because of what they create. During this relatively brief period and during this chaotic merger, a massive neutron flux ends up producing even much heavier elements, even elements like uranium. This usually involves the process referred to as the R process. And so basically a lot of much heavier elements seem to form during kilonova and not supernova. And though at first their existence was only speculated, as I mentioned, it was definitively confirmed in 2017. The historic event that you see right here. And so this iconic kilonova was the first time scientists detected gravitational waves linked directly to actual optical emissions, which essentially confirmed that neutron star collisions seem to produce kilonova. For scientists back then, this was a monumental discovery, and since then we actually have not seen anything similar yet. But that's until August of 2025, and specifically August 18th. Here, gravitational wave detectors LIGO, Virgo, and Kagra once again registered another bizarre signal, a signal indicating a compact binary merger. But crucially, around the same time, or almost exactly at the same time, the famous automated facility known as ZTF or Zwicky Transient Facility rapidly identified a burst of light that you can kind of see right here. And that's pretty much the same thing that happened in 2017. So here obviously a lot of astronomers were super excited because we might have just observed another kilonova linked to another gravitational wave event. And initially, for the first few days, it did indeed look exactly like this event from 2017. In essence, it faded pretty fast and produced a lot of very intense red glow, that once again suggested the presence of a lot of heavy elements like gold. And more importantly, gravitational waves and the optical event seem to be located in a relatively similar area of the sky. So here the correlation suggested that this was exactly the same event. But this is where the story got super bizarre. Following the first few days, the entire event changed completely. Unlike the previous detection here, it did not continue to fade and instead started to brighten again and again, eventually turning blue. But then it also started to display a lot of spectral features involving hydrogen and helium, which was completely unexpected and could not be explained through a kilonova explosion involving typical neutron stars. And so here this change suddenly made it look like a type 2b supernova, basically involving a young stripped envelope star, and not like a typical neutron star merger that we observed in 2017. And so what exactly was this? Was it neutron stars or a core collapse of a progenitor star without hydrogen layers? So here we had a completely new cosmic puzzle. And for the past few months, that's exactly what the scientists behind this recent study were trying to solve. They tried to figure out how a bizarre kilonova can then transform into a supernova just a couple of days later, which basically made them propose a new phenomenon, Superkilonova. Yeah, not particularly original. I mean, if it was me naming it, I would have come up with something like double boom boom or something. But I guess for now we'll have to go with Superkilonova. But that's not the only reason why this event is so bizarre and not the only strange observation. Because the strangest observation here is actually in what seems to have collided initially and the nature of this gravitational wave itself. Okay, let's briefly discuss neutron stars and black holes. So normally, a neutron star responsible for one of these kilonova is an incredibly dense remnant left behind after a core collapse supernova of a much older star. And while traditionally researchers always believed that a typical neutron star should have a mass of about 1.2 to maybe 3 solar masses in total, anything more than that becomes a black hole, anything less should be impossible. This is based on a lot of detailed simulations on how massive stars collapse and how they produce neutron stars. But the analysis of this gravitational wave currently suggests that one of these objects was less massive. Here the merger involved at least one neutron star that was actually even less massive than the Sun, a sub-solar mass object. But finding a neutron star below the threshold of 1.2 solar masses currently once again creates a bit of a problem. And that's because it creates a challenge for standard understanding of how massive stars evolve and how they go supernova. So even if it wasn't for the explosion, this was already kind of mysterious. And so this is why the scientists had to propose this new concept of double boom boom, Superkilonova. Here the term describes a kind of a core collapse supernova that simultaneously involves an R-process nucleosynthesis, usually associated with a typical kilonova event. And so here the model suggests a very bizarre chain of events. First, it involves some kind of a massive, rapidly spinning star. And here obviously the star becomes unstable because it reaches the end of its life. And so the star explodes as a supernova. This is a core collapse event. But because the star is spinning so fast, the collapsing core actually undergoes a kind of a splitting event, or even forms a disk of material that fragments into pieces. And so this may even lead to the formation of a very large rotating accretion disk. And this fragmentation results in the formation of at least one, but possibly two, subsolar mass neutron stars. But neutron stars that are super close to each other and are moving in extremely tight orbits. And so almost right after their formation, these brand new baby neutron stars start to spiral toward each other and then eventually merge, creating the gravitational wave signal and the kilonova's characteristic red glow. So essentially resulting in this double detonation. And so in this scenario, the supernova blast expands rapidly, overwhelming and obscuring the light from the smaller, fainter kilonova merger that happened inside of it. Which explains why the event at first looked like a kilonova, but later started to brighten and shifted color to resemble a typical core collapse supernova. And all of this was just a result of a large, fast-spinning star. And if this hypothesis is confirmed, it basically presents us with a completely new stellar evolutionary pathway, physically capable of creating these very bizarre subsolar neutron stars we actually never knew could be possible. And it obviously reveals that the universe is way more complex and can create additional objects we never expected. However, the team behind the study emphasizes one important fact. The gravitational wave signal and the light coming from this particular galaxy still has a slight chance to be completely unrelated. Or basically, just to rephrase this, there is still about 2 to 4% chance that this is a completely accidental alignment and the gravitational waves, along with the kilonova and supernova explosions, are maybe just completely separate events. And so to resolve this mystery, researchers are going to have to try to find additional similar events in the future, and will hopefully have additional telescopes observing them and analyzing the details. Especially because even in this observation, some things still don't make sense. For example, during a Kilonova event, we expect to see certain X-ray emissions and radio emissions which were not observed here. And so if this involved two neutron stars colliding, why was there no X-rays or radio emissions? Additionally, scientists discovered hydrogen moving at approximately 17,000 km per second, which seems to actually suggest that this was a Type II supernova, but the changes in color from red to blue made no sense. Either way though, this is definitely one of the more important scientific discoveries in 2025, because we've just never seen anything like this anywhere. Here, this definitely opens our eyes to potential categories we never explored, and basically presents us with astronomical sources we never considered. And if confirmed, the Superkilonova model proves an entirely new stellar evolutionary pathway that seems to form really bizarre and really tiny neutron stars. And so hopefully, if such an event happens again, researchers will get to observe it with telescopes like the James Webb, because here, by observing infrared light, it might become possible to confirm the composition of the explosion and specifically discover certain elements mixed inside the supernova ejecta. And so by knowing the composition of the ejecta, it may become possible to confirm certain observations. Right now, we unfortunately only have color. And so until future discoveries, or until someone actually figures out what happened here, that's pretty much all I wanted to mention. We'll definitely come back and discuss this more once there's some additional propositions or additional observations. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon, where you can find additional videos without any ads and can DM me directly, or by joining channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.